We want to find in part A the sketch of a graph of a function that has two local maxima, one local minimum, and no absolute minimum. Part B, we sketch the graph of a function that has three local minima, two local maxima, and seven critical numbers. Let's start with part A, that is, a function that has two local maxima, one local minimum, and no absolute minimum. It seems to be easy in this case because we have something like this, where we have, let's see, two local maxima. So we have this point here over here is a local maxima, and this point over here is a local maxima. So we have two local maxima only in this graph. We have then one local minimum, and this one is here. One local minimum. There is only one. And now we want no absolute minimum. And in this case, let's see that the lowest point in the graph, which should be the absolute minimum, should happen here, but the point has been removed. Just the image of this value here has been put this here up. And for that reason, we have a graph of a function that does not attain its lowest value. So we can say that in this graph there is no absolute minimum. There is absolute maximum, but no absolute minimum as we wanted. So two local maxima at those points here, here, and here. One local minimum at this point. Sorry. And no absolute minimum. Because we have this behavior here on the lowest point should be here, but we have removed the image and put it above in order to not attain the absolute minimum. We could do something similar if we don't want an absolute maximum. That is, we can put the highest point of the graph to the right and remove that point of the graph and put it up below. That's the similar case for no absolute maximum. So we have these three property on this graph. Okay, now we go for part B, which should be a little bit more interesting, and we see the following. We have three local minima, two local maxima. It seems that there are already there five critical numbers. We need two more to have seven critical numbers. So we have drawn this, and as we can see here, we have, let's do it with the statement, three local minima. So we have here, local minima here, local minima here, and local minima here. So we have three local minima. Then we wanted two local maxima, and we have them up here and here. It could be differentiable. There is no need that is be like this, but I did it this way. But you can have a perfectly differentiable function here and here, and each of these local maxima and minima. So two local maxima at these 2 points, as we said. And now we have these five points here are critical numbers because they're We have either their derivative, in which case it should be zero because they are local extremes, or these are points where there is no derivative, like this in this example, and they are also critical numbers because they are in the domain of the function and the derivative does not exist at those points. So it means that we have already with this property here, we have five critical numbers, so we need two more. And the idea is to make the graphic discontinuity with the jump discontinuity like this. And with this graph, we don't have neither local minimum nor local maximum at these 2 points. Because if we take any interval around those points, there is always images that are greater than the image at the point and lower than the image at the point. So these 2 points are no local extreme values, but they are critical numbers because they are in the domain of the function. We have put images to those points. In this case, we have put the image up here and here at this point. We have put it up here, here, this case here, and here in this case here. So the points are in the domain or the values of the numbers, and there is no derivative, so they are critical numbers. So we have these two anomalies near the endpoints of the domain in order to add two more critical numbers, but which are not local maximum nor local minimum. So that's the idea behind that. So I take this out a little bit. And so this is an example solving part B. And we had this a little bit easier in part A. And that's it.